Okay, here we are in the lab again, and so we got a couple new things. We got a new whiteboard back there, and a couple new wireless microphones. So we're getting there. I just need to get a longer cable, USB cable for my camera, and so it can get a little bit closer to the board, and then we can do some board work and stuff. But but right now is just a quick introduction of MainBrain, what the theory is, the idea behind MainBrain, why did I start MainBrain, and all that stuff. So MainBrain, I started the MainBrain project because I wanted a microcontroller for all my projects. I didn't want to have to like design a new microcontroller circuit every time I build a project. I just want to be able to use MainBrain to control whatever I make, whether it's like a power supply or some kind of like an interface, like my motion board, control motors, anything. MainBrain should be able to interface, and it shouldn't be anything MainBrain shouldn't handle, because the fundamental principle behind MainBrain is you have a central microcontroller that interfaces with a dual port SRAM. And so that allows the microprocessor, the microcontroller, to take care of all the onboard stuff like the display and the touch screen, and monitor the power supply and whatever else your program requires. The USB, it's got to communicate with the PC back and forth. MainBrain has a USB port that interfaces with the PC so that you can control it with the PC and get data transfer back and forth. And it's a high-speed USB, so that means it can transfer like 480 bits per second, which is pretty good. I mean, that's a lot of data you can work with. So that's the basic idea of how MainBrain communicates to the outside world, is through that dual port SRAM. So on on board of MainBrain, we have 4 MB of flash memory to store. It's external to the microcontroller, so it's just user data. Four megabytes of user data, and we have an onboard power supply. It has its own switch mode power supply. It can handle up to 3 amps, which is very robust, I think, because MainBrain itself, even with the display, it only takes about 350 milliamps to run. And then with the peripheral on there, maybe, that can go up. And MainBrain does supply 3.3 volts out through the output ribbon cable, and a reset signal, and to the peripheral. So it can power a peripheral up to 3 amps. I don't think you'd want to suck 3 amps out of it across the ribbon cable, though. But yeah, the power's there. Then it has a display, a touch screen display, a capacitive touch. I tried to use the resistive touch displays, and it's really hard to switch the ADC on and off for the columns and the rows, switch it back and forth and read the position. It gets a lot of noise in there. And I still have a little bit of noise on the main board circuit for the ADC. So it's a little noisy, but it's not bad. It's down into the 20 millivolt, 10 millivolt range, so it's not too bad. But we're working on that too. And so the display is a 16-bit, well, actually an 18-bit. Normally, MainBrain communicates to the display in 16-bit data bus, but you can bit bang 2 extra bits because the display is 18-bit. It just depends on how much color and resolution you want. It's basically color. Everything else is 16-bit, and a lot of the commands are only 8-bit anyway. But yeah, that's pretty much MainBrain. is there anything else it has? Well, it monitors the board voltage and current. So, well, the input voltage, because MainBrain runs on from like, I think it could go down to 7. We have to test that. That's part of what we're going to do. It can go down to maybe as low as 5 volts, and its maximum is 24 volts input to the board. So you can just plug in anything between 5 and 24 volts DC, and MainBrain should power up and not have a problem. And so it monitors that just so that you can, I display the input voltage on my Windows program, and also MainBrain monitors the current of the 3.3 volts that powers the main board. And also that 3.3 volts, like I said, goes out to the peripherals. So as you stack peripherals, that current's going to go up. So we monitor the current, MainBrain monitors it, and displays it also on the PC app. So basically, that's the idea of MainBrain. You can control it either from the PC, or you can program it to be controlled by the touch screen. So then we'll get to the main board on the next video, and I'll draw diagrams and we'll talk about more details about it, because it has a reset supervisor on there too, and also a buzzer. I almost forgot. It has a buzzer, so it beeps when it powers up, and it has a 8 LED status port. So the user can use that status port to write different things. It's great in debugging and stuff like that. And so we'll get into that too. And then it also has what microchips debug interface port is called ICSP, and it has a 5-pin ICSP port. So you can plug in the microchip PIC Kit 3 or your debugger of choice from microchip, and program the microcontroller, get the program in there and change it and debug it and whatever you need to do. So that's pretty much it for today. And like I said, we'll get back on the board and do some more theory, and we're getting there. We're going to get down into some theory here pretty soon. All right. See you next time.